Hi, in today's lesson, we're going to be looking at the ways that lines interact with each other. So recall, we've already looked at some pairs of lines. We said lines that have the same slope are called parallel. And the symbol for parallel is just two little parallel segments. And parallel lines never intersect. Okay? When you see parallel lines, you either need to be able to prove that they're parallel, finding their slopes, or a lot of times if they're just drawn in a picture for you and they're not on a coordinate grid, so you can't find their slopes, you'll see this little triangle on each one, and that indicates that you have parallel segments. Or lines. We can't ever just assume things are parallel unless there's some way we can either calculate the slopes or we see the notation, kind of like tick marks on congruent segments or arcs on congruent angles. Okay? So we need those triangles, or we need to be able to calculate the slope, or in the prompt of the problem it needs to tell us that the lines are parallel. And then we'll know that they never intersect. Then we talked about lines that have slopes that are opposite, meaning one's positive, one's negative, and they're reciprocals, meaning the rise over the run have been switched. We said that these lines are called perpendicular. And we know the symbol for perpendicular is an upside down T. This means those lines are going to intersect at a 90-degree angle. Okay, so when I see these two lines, we're going to have one and another one. No matter how much they look like they intersect at 90, unless we can find their slopes and prove that they're opposite reciprocals, or it tells us in the prompt that they're perpendicular lines, or we see that we have 90-degree angles with a little box, we can't just assume that two lines are perpendicular just because they look like it. Okay? We also talked about if lines intersect but not at 90 degrees, then we call those lines oblique. Okay, so don't forget about that relationship. That's not going to be on our lesson for today, though. The third one is a new one to us. We haven't seen this one yet. Lines that never intersect, so kind of like parallel, but they don't have the same slope. We call these lines skew. And what's important to know about skew lines is they can't exist on a piece of paper. They only exist in our 3D world, okay? So they only exist in 3 dimensions, okay? You can't do it on a 2-dimensional piece of paper, not on a flat sheet of paper, okay? Let me show you an example of skew lines. So here I have a box of tape. Okay, it's just a little box of tape. If I sit this like this and I look at these two segments, this pink segment here and this pink segment here, it looks like they're perpendicular. It looks like they're going to intersect right here at 90 degrees. But if I pick this box up and I turn it, we can see that no, in fact, those two segments, they're not going to intersect because even though they run in different directions, so they don't have the same slope. This line here is vertical, so that's an undefined slope. This line down here is horizontal, so that's a 0 slope. So they have different slopes, but because they're in different planes, they're not going to intersect each other. Okay? We call these lines skew lines. They're not parallel, they're not oblique, and they're not perpendicular. These are called skew. They won't intersect each other, but they also are not parallel because they don't have the same slope. Okay? So we call these skew lines. Okay? So on a 2-dimensional sheet of paper, the only way we can identify where skew lines are is if we draw it on a 3D representation on our piece of paper. Okay? So it wants me to identify the relationship between the lines drawn in each rectangular prism. It's important that it tells me it's a rectangular prism because what I know about rectangles is I know opposite sides are parallel, and I know that the corners of rectangles come together at 90-degree angles, okay? So when I look at these two lines here, I can see they both are on opposite sides of this rectangle, so that means they must be perpendicular, or not perpendicular, they must run in the same direction. They must be parallel. Okay? when I look at these two lines here, okay, thinking about this cube that we have, this prism, that it's really a 3D image, it's just flat on our paper. So on my paper, if I were to extend this, it is going to intersect here. But if this was an actual 3D cube, right, it would be kind of like this one here, where I would just take this and move it to this back corner, and then I'd still have this one down here along the bottom, right? So this one would be like here. So again, these are not in the 3D world, these are not going to intersect each other, right? So these would be considered skew. And there's no markings that we can put on the picture to show that we have skew. We just have to be able to visually recognize that they're skew because they're in different planes and they're not going to intersect, but they don't have the same slope. Okay? All right, when I look at the next one, these are both on the same plane. They're on the front of this box, okay? And they are going to intersect right here. And since I have a rectangular prism, I know all the corners are 90, which means even though it wasn't marked for me in my picture because the prompt tells me I have rectangles, I can confidently say that these are perpendicular. And if you don't want to write out the whole word, you can use the symbol, right, the upside down T. Okay. All right, when I look at my fourth box or rectangular prism that I'm looking at, and I have those two lines, and I want to know what their relationship is, they are in different planes, and parallel lines tend to be in the same plane, but remember, planes can be invisible. I could draw a diagonal wall through this, like think if this was like a parking garage and it had a ramp, right, that took you from the lower level to the upper level. You could draw a flat surface that these two would both be on, and they would both be running the same direction. So these we would say are parallel. And again, even though the markings weren't already there for me, because I know I have a rectangular prism, all the sides are rectangles, and opposite sides of rectangles are parallel. So this piece is parallel to this piece. This piece is parallel to this piece. So that means all of these pieces are parallel. Okay? All right, the last one is a little bit different when we look at this one to try to figure out what this one is, because on my paper, they are actually intersecting, right? They're touching right here. But think about where the lines are. This line here is on the back of the box, and this line here is on the front of the box. So my horizontal line's on the back of the box. My vertical line's on the front of the box. So if I have one on the back of the box and one on the front of the box, those boxes, unless you collapse the box, are never going to touch. So these are skew. Okay? So we have skew lines there. So parallel, skew, perpendicular, parallel, and skew. Okay? All right, the last thing we're going to talk about in part one to kind of lead into what we're going to do in our second video is we're going to look at some angle relationships that are formed when lines intersect. Okay? And we've seen this a couple times this year. So we know when lines intersect, we're going to have a linear pair. Because think about if I have two lines that intersect. If I think about this line or this angle here, and I compare that to this angle here, okay, I know that together those lines or those angles are going to form this line. And I know on one side of a line, so they're adjacent and they're supplementary, so they're right next to each other, and they add up to this whole line, which is 180 degrees. Okay, so and we really have four pairs because I've got the ones on top, I've got these two here on the side that would add up to 180 and be a linear pair. I've got the ones on the bottom, these two would add up to 180 and be a linear pair, this angle and this angle. And then I have these two over here, this angle and this angle are a linear pair. Okay, so I have four sets of linear pairs here. Okay. Another type of angle we talked about when lines intersect are vertical angles. They're across from each other when two lines intersect, and they are always congruent. So when I have two lines that intersect, anyway, they could be oblique like these. They could be perpendicular. That would be fine too. we're going to have vertical angles that are across from each other when the two lines intersect. So I'm going to have these acute angles, this one here, will be vertical to this one here. And then we also have the set of obtuse angles, the one up here on top and the one down here in the bottom. Okay, and these two are congruent to each other, and then these two are congruent to each other. They are vertical angles. My purple ones are vertical, and then my red ones are vertical and congruent. Okay? So if I look at my two types of angle, my vertical angle and my linear pair, it's asking me, do these relationships have anything, or these angle relationships, the vertical angles and the linear pairs, do they have anything in common? Okay? Well, I know my linear pairs are adjacent. That means they share a ray and they share a vertex, right? And I know that they add up to 180. Okay, so let's see if these angles down here do any of those things. Do they share a ray, do they share a vertex, or do they add up to 180? Because that's really all we know about a linear pair. So when I look down here, they don't have to add up to 180, right? Because I've got an acute angle here and an acute angle here, and two acute angles isn't going to be big enough to make 180. Here I've got an obtuse angle and an obtuse angle, so they're both bigger than 90. If I add two numbers bigger than 90 together, that's going to be bigger than 180. So they don't have the 180 in common. Do they share a ray? So this pink angle or purple angle has two rays that go both off to the right. This purple angle has two rays that both go off to the left. So they don't share rays. So the only other thing they could have in common is, so we share a ray, we share a vertex. Look at the vertex for the vertical angles. They share this vertex. The top and bottom angles share this vertex. So my linear pair angles share a vertex, and my vertical angles share a vertex. So the the angle relationships that we looked at here, angle, linear pair, and vertical angles, they both are at the same vertex. They share the same vertex. Okay? That's going to be important distinction to make when we're looking at the new angle relationships that we're going to start when we get into transversals in the next video. Okay? Thank you so much for watching, and I look forward to seeing you in the next video.